Greetings and welcome to this session of our flipped classroom. We're working with problem set number 2, and this is from section 5.5. And we are going to work with half angle identities today. So on page 415, we'll be working with 35 through 40 and 41 through 51 odds. Hey, isn't that cool? There's this man in my room. Okay, not really. I'm the man in the room. Really, that is our overhead speaker. So I do that for sound effects to give more of a 3D feel to your presentation. So anyways, as I was about to say, I will do some of these problems, and I may do some evens that aren't necessarily on this problem set, but are contained within it. For example, I might do 46 or 48 or something like that. So let us begin. If I look at lesson 35 through 40, they ask us to use the following triangle. Now it is a right triangle, so I'll need Pythagorean theorem to get the hypotenuse. And when I work that out, a quick check, you can verify that it will be 17 for our hypotenuse. Now I knew this ahead of time because I want to save you a little bit of time here and there. I have for you the sine, the cosine, and the tangent. So they're all set up for any of these problems. 8 over 17, 15 over 17, and 8 over 15. Now the sine theta over 2, which is a half angle identity, is represented with a radical 1 minus cosine theta over 2. Now this is all under that radical. So we're going to then substitute in. And the only part I can substitute for is my cosine theta. My cosine theta is told to be 15 over 17, and this is all over 2. If I work the problem, I'm going to want a common denominator on top, so I will have, without skipping a step, 17 over 17 minus 15 over 17, and this will be divided by 2. Or it will leave me with 2 over 17 all divided by 2. That then, let me slide that up a little bit, that then will give me a radical 1 over 17, or 1 over radical 17, which by rationalization techniques, as you recall, we can always multiply by 1. Radical 17 over 17 is in fact 1. By solving this, we end up with a radical 17 all over 17 as a rationalized solution. Now I'll skip to 38. And 38 I chose because it is secant theta over 2, and we don't have a half angle identity set up for secant. However, we can remember that it is a reciprocal of the function or trig function cosine. So I could write it as this first setup, 1 over cosine theta over 2, or I could just solve for cosine theta over 2, but then it would require that I remember to flip my solution because it is a reciprocal function. So either way, we could handle this problem. I will work the one that feels most likely for me to succeed without making a mistake. In other words, I prefer the other way, but if I forget to flip it at the end, I will not have the right solution. So, stepping us through this problem, we see that we have cosine, or 1 over cosine theta over 2. We need to look at our cosine identity with the half angle, and that leaves me with a 1 over a square root of 1 plus cosine theta all over 2. If I do a quick substitution, I will have 1 over, in radical, 1 plus, well, we just did a similar problem to this, which will give us our 15 over 17 again, all over 2. That then will be reducible and will give us a 1 over a radical. In this case, we're changing the 1 to a 17 over 17. So I will have a 32 17ths, all divided by a 2. Now when I divide that by 2, I will end up with the problem of 1 over, let's see here, 1 over 16 over 17, which will need to be changed to 1 over 4 radical 17. The nice thing about this one is that I have a fraction in the denominator. So my 1 is divided by this fraction. So I'll bring it up on top and I will flip it, or use the reciprocal, which puts the radical 17 on top in the numerator and the denominator as a 4. So I am done. No rationalizing needed. Just in note, I could have solved, as I said, for the cosine in the numerator and remember to flip my solution at the end. And if you hang with me real quick, we will see that we get a 1 plus 15 over 17 all over 2, leaving me with a radical of 32 17ths over 2. Now we've seen this before. That will give me the fraction of 16 over 17, or 4 radical 17. And now I'm tempted to rationalize, but this being my solution, I now reciprocate it. So the reciprocal will give me or yield a radical 17 over 4. In this next problem set, 41 through 48, they ask us to find the exact values. And so we're going to find the exact values, and in this case, they want us to use the half angle formula. And so what we need is we'll need to double our given value. So they give us some angle values. We're going to have to double those. And then we can use our half angle formula. So let's see how this is done. So I guess I'm going to do 44 and 48. I realize they're not your actual problems, but they will show me or show us how to work out each of these problems. So in note, I'm just going to tell you that the 67 degrees is going to need to be processed as a decimal. And so I have my 67 degrees in my 30 minutes. That really is nothing more than 67.5 degrees. And I double it. And when I double it, I get 135 degrees. Now for 48, I will see that I need to double a radian measure. So doubling this radian measure really means that I will have the denominator, so my 12 becomes a 6. So let us begin. Let's look at a couple of these problems so you can do your problem set. So A says sine of 67 degrees 30 minutes equals sine of 135 degrees over 2. These are equivalent. So once I have this, I can work my math magic, so to speak. Let's see how we do. So I'm going to have a radical of 1 minus my cosine of 135 degrees, and that is all over 2. Now it's really nice because 135 degrees I know is radical 2 over 2. And you can again verify this on your charts. or by now we start to recognize some of the repetition that we've had throughout this trimester. If I work this at this point, I simply see that I could rewrite the top as a fraction of, and in this case, a 2 minus a cosine of radical 2, and that would all be placed over 2, divided by this 2 we have in the bottom. So in essence, what I have left then is a 2 minus cosine of radical. Oh geez, you know what? I did what I say for you not to do, which is we don't have the cosine, we have a value here. Let me just get rid of that cosine. It just was not feeling right here. So I have this cosine 2 all over 4 at this partition. So what I'm going to do is I'm going to simply factor out a 2 over 4, or sorry, my 4, which will give me a 1/2 outside of our radical, and a 2 minus radical 2 inside. And this is as far as we're going to take this for our purposes. Now let's be a little cleaner on this one. Again, we're going to do the same technique. Now notice, when I take this radical, this time it is a 1 plus cosine of 135 degrees. Over 2, excuse me. And when I get this time I will have my 1 plus, and without making that mistake, I'll see a radical 2 over 2 all over 2. Solving this, I will then have my 2 plus radical 2 all over 2 divided by that 2 in the denominator, which will leave me with 2 plus radical 2 all over 4. So 1/2 taken out, leaving me with a 2 plus radical 2 inside. Let's just see tangent real quick, and then I think we're going to be done with this lesson. I don't think I'm going to get any farther. And the tangent reads a little bit differently. That says take the sine of that 135 over 1 minus cosine of 135 degrees. And then if we solve this, we'll end up with a radical 2 over 2, and then a 1 minus radical 2 over 2. Again, I'm going to rationalize that denominator, so I have a radical 2 over 2 all over, in this case, I will have a 2 minus a radical 2 all divided by 2. When I bring this up to the top and multiply by the reciprocal, what I will end up with then is the value of 1 plus radical 2. With the remaining few seconds I have, I guess I would like to just real quickly explain how this was solved as a 1 plus radical 2. So when I multiply by the reciprocal, I will end up with a radical 2 in the numerator and a 2 minus radical 2 in the denominator. Now, seeing our rationalization technique, I'm looking for a conjugate pair, the 2 radical, or the 2 plus the radical 2 in the numerator and denominator. That will leave me with 2 radical 2 plus 2 all over 2 minus, 4 minus 2. If I simplify that and put it in descending order, I will have a 2 plus a 2 radical 2 all over 2, which ends like that. Thank you, and have a good day.